Okay, welcome to this page of the notes, and now let's take a look at rhombuses and the conditional statements for showing that a figure is in fact a rhombus. So let's take a look at these. There are 3 of them, all of them based on the properties of rhombuses we've already looked at. So one at a time here, let's run through these. Again, as long as we know it's a parallelogram. If any one of these conditions shows up, we'll know for certain, based on the theorem, that it must be a rhombus. Here's the first one. If one pair of consecutive sides of the parallelogram are congruent, then the parallelogram is a rhombus. And of course, we know that because rhombuses have consecutive sides that are congruent. That's a property of a rhombus. So we can use that to show that a parallelogram is a rhombus. Then we also know that for a rhombus, one of the properties is that the diagonals are 90 degrees to each other. That's a property of rhombuses. So if I'm given a problem where I am shown that I have diagonals that are 90 degrees, then it must be a rhombus. That's exactly what it says. If the diagonals of the parallelogram are perpendicular, 90 degrees, then the parallelogram is a rhombus. We can use that property of rhombuses to show that a figure is a rhombus. And then of course, we know that one of our properties of rhombuses is that the diagonals bisect opposite angles. Well, that means then, if one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram must be a rhombus. So hopefully you're beginning to see here exactly what it is we're doing. We're simply taking the properties of rectangles on the previous page of the notes and now taking the properties of rhombuses, and we're using those properties to prove that a figure is or is not a rhombus. So let's take a look at a couple of example problems, which I've got for you right here. So what I've done is I have given you a figure. I've given you some information about the figure. Let's go ahead and see what we can do. I want you to determine if the conclusion is valid. So say, is it true or is it not true? If it is not true, I'd like to know what additional information is needed to make it valid. Here we go. What I've given you for this figure right here, this diagram right here, is I've told you that AB and CD are congruent. Okay, great. What that means is I have opposite sides that are congruent. Okay. Then I tell you that BC and DA BC and DA, once again, look at that, opposite sides are congruent. So here's what that means. Just this information right here tells me that the figure is a parallelogram. Parallelograms have 2 pairs of congruent opposite sides. So this first bit of information right here is just simply me telling you the figure is a parallelogram. Okay, great. Now what? Well, can you prove? All right, can I prove? Can I prove that the above parallelogram right there, is a square? Okay, interesting. We haven't talked about squares yet. Well, remember we talked about squares in the previous section, so we're going to remind you of a few things here, but let's finish the question. It is sufficient to show that the figure is both a rectangle and a rhombus in order to prove that it's a square. Now, hopefully you remember that from the previous section where we talked about rectangles, rhombuses, and squares. What we said is that a square is the figure you get when you sort of mesh the properties of rectangles and rhombuses together. Remember, rectangles, all 4 angles have to be 90 degrees, which of course a square has. Also, a rectangle has diagonals that are congruent, which of course a square has. But then for a rhombus, well, the properties of rhombuses is that consecutive sides are congruent. And of course in a square, all four sides are congruent. Then, for a rhombus, the diagonals have to be at 90 degrees. Well, of course, for a square, the diagonals are at 90 degrees. And then finally, for a rhombus, the diagonals must bisect opposite angles. Well, that's absolutely the case for a square. In a square, the diagonal will split opposite angles into 45 and 45 degrees. So what we see here, right, is we take the properties of rectangles and the properties of rhombuses, and we put those properties together, and what do you get? You get a square. So what we're going to do in this problem, hopefully, is show that this figure right here is both a rectangle and it is a rhombus. And if it's both, what that means is the figure is actually a square. So here we go. Let's take some of this information right here. Let's see, what do I tell you? I tell you that AD, so AD is perpendicular to DC. DC. Okay, remember, perpendicular means 90 degrees. So here's what that tells me. AD is perpendicular to DC means I have a parallelogram with one right angle. What does that mean? Well, go back to the first page of the notes. I gave you that table that lists the conditions for a figure being a rectangle. This was the first one. If I give you a parallelogram and that parallelogram has one right angle in it, then the conditions, the theorem says it must be a rectangle. So right here, this is enough information. Just that right there is enough information for me to say yes, this figure is a rectangle. So, A, B, C, D is a rectangle. Yeah, is a rectangle. All right, great. Here we go. Let's keep going, because I still have another piece of information, which is right here. Let me pick a different color to write in. We'll go with green this time. All right, so right here. All right, what does that tell me? Well, let's see here. AC, that's a diagonal. AC is a diagonal. I tell you it's perpendicular to B. Boom. There it is. This piece of information right here tells you the diagonals are 90 degrees. So, AC is perpendicular to BD means the diagonals are perpendicular 90 degrees to each other. Well, this is a property of rhombuses. We just looked at it on the previous page. Go back to the previous page of the notes. It was the second condition for rhombuses. If you can show the diagonals are perpendicular, then the figure must be a rhombus. So, means the diagonals are 90 degrees. So, A, B, C, D is a rhombus. Well, that's it, right? All I needed to do, I tell you right here, it is sufficient to show the figure is both a rectangle, I did it right here, it's a rectangle, and is a rhombus, I did it right here, it's a rhombus. That's enough to prove that it is a square. So, therefore, A, B, C, D is a square. Awesome job. Here we go. I got another one for you right here. Let's see what happens. Okay, so I tell you that it is a parallelogram. I want you to prove that it is a rhombus, A, B, C, D. Sorry, we're using, right here, using the exact same figure. So let's see what we can say. Well, here's what I tell you. I tell you that AB is congruent to BC. Okay, so ignore the markings that I already have on it. In fact, actually here, I will just redraw it right down here. A, B, C, D, I had the diagonals running through there. And here's what this guy tells you. This guy is simply telling you that AB is congruent to BC. AB is congruent to BC. Well, what did I tell you? I just told you that consecutive sides are congruent. That's the first condition, right? That's the top condition in the table on the previous page for rhombuses. If you can show that one pair of consecutive sides are congruent, then the figure must be a rhombus. So, AB being congruent to BC shows that one pair of consecutive sides are congruent. Therefore, ABCD must be a rhombus. Therefore, A, B, C, D must be a rhombus. That's it. That's all we're doing here with these particular problems, using those conditions for rectangles and rhombuses to prove that parallelograms are or are not. It's possible they may not be. So what I've got for you on the next page of the notes is another example problem. I'll meet you there.